Managing a project involves many different but interrelated factors: cost constraints, the availability of personnel, and the demands of quality control, amongst other things. But this programme on project management and critical paths will specifically focus on some of the mechanisms for managing time. When mapping out a project, it's important to make as accurate an assessment as possible of the time taken to carry out the works. In simple terms, an architect will usually sketch out a plan of various phases and activities from the plan of work to best assess how long it's likely to take. From this position, an assessment can be made of whether the resource allocation can be adjusted, budgets tweaked, or value added. This programme will explore the basic concepts of critical path analysis and how to understand the critical path method for various projects of varying size and complexity.
And to discuss some of these issues, we're very pleased to have Martin Powell, Director of Project Delivery at the London Development Agency, based at Will Alsop's Palestra building in Southwark. A very warm welcome to you, Martin. Thanks for coming in. Can I just start with what I would like to say is an easy question. Just if you can explain what project management is, and specifically taking a look at risk management, quality management issues, where they differ. What is project management?
Yeah, very simply, project management is an approach to the successful delivery of a project. The fundamental principle is that you make a guess right at the beginning and you turn that into a plan of a set of planned activities which enable you both to manage the project and also control and monitor the project based on your original plan. Probably the most fundamental thing to remember is it's just a plan and things will change, but that's all part of the process.
So it's just a guess?
It's a guess at the beginning, and it gives you the opportunity to understand when you veer away from your guess. And as you go through your project, obviously you learn more information, you bring in more design work, more experts, and as you go through the project and understand what you're trying to do, you're able to improve and refresh the plan as you go through.
Okay, because architects always argue that project management is part of what they do. It's almost like rightfully theirs to project manage a job. So what skills do you or do project managers in general bring to a job?
Yeah, I think fundamentally a good project manager has a very, very clear understanding of the project objectives. They'll work very hard at the beginning to get a common understanding of what the project is trying to do, and then they'll manage that within the time, cost and quality criteria. I think they need to be very single-minded in terms of driving towards that end objective, but they also have to be reasonably open-minded to changes as we go through that path of the project.
Right, well, we'll look at some kind of simple models in a moment, but just to put us in the picture, can you just give us an indication of some of the jobs or complexity of jobs that you are working on at the LDA?
Yeah, we have a portfolio of around 400 projects, of which around 80 of them are reasonably large capital projects. That totals approximately £100 million worth of capital spend, which we deliver each year on projects relating to housing, infrastructure, and also combating climate change.
Okay, so in terms of first principles then, I suppose, about critical path analysis, can you just explain what a critical path is and how it differs from a critical chain analysis or those types of other phrases that are commonly bandied around?
Yeah, a critical path very simply is the longest continuous path of activities through a project, which will determine the end date. Very simply put, if you look at any sort of Gantt chart, and we'll come to one later, but if you turn it on its side and let everything fall away, the longest chain of activities left is actually your critical path. The critical chain really tries to protect the activities, the time and duration of those activities by focusing very much on resources. And so your critical chain through your project might be very different from your critical path because of the resource constraints that you may have through the duration of your project.
Right, right. So critical paths are, as you say, often drawn as flowcharts or as Gantt charts. So can you just go into a little bit more details to what a Gantt chart is and really explain the differences, what maybe a flowchart can do that a Gantt chart can't, and vice versa?
A flowchart fundamentally describes a process. So a project network diagram is an example of a flowchart. A Gantt chart is a sort of illustration of the key activities within a project in terms of their start and end date and some of the work associated with each of those activities.
Right.
Let's look at a simple build-up of a critical path diagram using an abstract project with 5 activities: A, B, C, D and E. For the sake of this exercise, A, C and D take 5 days, B and E each take 8 days. Importantly, action A and B are independent of one another. C can only start when A is complete, D can only start when C is complete, but E can only start when both A and B are complete. So how might these be represented on a flowchart to determine the actual program duration? From the start date, A takes 5 days. C follows A and D follows C. Remember, C and D can only begin after the preceding event has been completed. This leads to a notional program duration of 15 days. But activity E can also only start after A, that is 5 days after the start date. However, as we know, E can also only start after B, an activity that takes 8 days, pushing back B before the start date. But A is the start activity, and therefore B must be brought back into line to at least the same position as A. This shunts the program out to a critical timescale of 16 days.
Well, you join us at this high-tech 1970s display board. That was a simple project that we just saw, Martin, but there's more complex activities that we can bring into play. First of all, PERT, P-E-R-T, Project Evaluation and Review Techniques. Can you just explain what that is for slightly more difficult, complex jobs?
Yeah, it's simply a process that enables you to determine and look at the impact of durations of different activities on a project.
Good. Well, because here we've got a typical example of a dwelling house. Some times have been allocated from excavations all the way through to landscaping. Could you try and draw for us a critical path on the board and just see how it all pans out?
Okay, well, we'll start with some of the activities. We'll take the top one, which is excavations. And very simply, if we draw that, it's a 2-week activity. If we look at the foundations next, we've got 3-week activity. And what I've done there is started that with a lag of 1 week. So I can start excavating and then doing the foundations. Also, as I do the foundations, I can probably start some of the drainage. And we have a 4-week period for this. And again, I can start some of the drainage shortly after I've started the foundations. Now, the drainage may have some float, and we'll come and talk about float in a minute, but this activity may be able to go on beyond the 4-week duration that we've shown. We can then do the floors, and I can probably start the floors right after I've done the foundations, and that's probably what we would call a finish to start activity. We would then, right after the floors, go straight to the walls, where we have 8 weeks. Now, I might do that in 2 lifts, but in this case, we'll go for 1 straight 8-week duration. We can bring in the bricklayers and they can build this house right up to the top. So that's the walls depicted, again, on a finish to start activity from the floors. We can then go to the roof. Very simple 4-week duration, and obviously we can't put the roof on until we've done the walls. You can have a go, but I don't think you'll be particularly successful. And then we've got electrics, which are 3 weeks. So we'll do what we call first fix electrics, and we'll make that 2 weeks. Because then we've got to do some decoration, which will also take 2 weeks. And then I can do 1 week of second fix electrics once I've got the wallpaper on. And then the landscaping can start probably at any point. So let's just show that. Probably after the disruption of the bricklayers and the roof, we can probably start the landscaping early, which gives me 2 weeks of float to meet the end date of my project. And this actually is free floating. It can start at any point.
Right. Can you, apart from the fact there's windows to go in there, fundamental to the British construction industry, I think, being able to see out of the walls. But can you just explain what this float is, and contingency as well, since you mentioned both?
Very easily. We can very easily draw a critical path through this. We just need to make sure we've got all of the dependencies on. So we have the earthworks need to be complete before the drainage starts. Everything else seems to have the right activities in place. So let's just add the windows in right after the walls and windows, 3 weeks. And we can probably run that with the roof. Okay, so we have, again, another activity here. And actually I've got time. I can actually wait and do the windows until the end of the project. So this is my float on the windows. I have a lot of float on the drainage. In theory, I probably need to complete that by the time I start the landscaping. And what we can now do very quickly is show the critical path, the activities on the critical path. We'll rub that one off. And as you can see,
So it's those start to finish dates that you're highlighting.
exactly. The key with the critical path here is if any of these activities I've shown in red slips by just 1 day or 1 week, for example, this one, any of these, then my end date is going to slip by 1 week.
Okay.
As you can see, the drainage and the landscaping and the windows all have what's called free float. So you cannot have any float on your critical path activities.
Right. And in terms then of contingency building in, because these are very clearly start-finish dates, but presumably, since we started talking about it being guesstimates, presumably you have to build in some contingency network here as well.
Yeah, exactly. When you first start a plan, obviously with a house, it's much easier. Houses have been built before, they're largely built the same way. So our guesstimates ought to be reasonably good estimates. In more unique projects where there's a lot more uncertainty, the best thing to do is to try and build in some risk factors on your activities. So you might start showing some pessimistic, most likely, and optimistic examples of how long those activities take. The benefit of doing that is that you are clearly demonstrating your level of risk on each of your activities through the project. Fundamentally, what a lot of projects tend to do is add a 10% contingency at the end. I'd be more inclined to add 11% to make it look like I actually thought about it.
That's 10% on your 10%.
10% on your 10%. The best approach, obviously, is to put contingency on each of the activities. The reason for this is if you are a house builder building 1,000 houses and you're halfway through your projects or halfway through your year, you can actually then determine by activity how many of the activities were completed on time, and therefore you can see how much contingency you could release back into your business. The benefit of that is it means that midway through the year you can make an assessment of how many more projects you could start commencing and investing in more houses.
So this is a process of constant monitoring. So you start with a best guesstimate, and then you constantly appraise the actuality throughout the project, the process, to fine-tune things further along the chain. Is that right?
Exactly. The initial plan needs to be drawn up much like this. Some people use yellow stickies. All big projects, Millennium Bridge, Millennium Dome, current Olympic projects, were all built up from very, very simple logic like this. When you control your project, using Gantt charts and tools like this enable you to manipulate and view progress on a project on a daily, weekly or monthly basis.
Right. And what if then, say, your windows were on a 15-week delivery?
Okay, then simply you have a look at your original plan. You can see that I need to start putting windows in week 14. So it would actually mean I need to order them a week before I start. So I either have to push the start date back, or my commitment to the project needs to be pushed back, or have a look to see whether I can push the windows further into the program. And in this case, as you can see, I could actually reduce some of the float and turn this into a much later activity.
Yeah, so you've got 6 weeks float there, so if you only discovered that the window's going to be on such a high delivery, you've got 6 weeks to play with the program.
Exactly, which is a reasonable time for me to procure windows.
Right. Can we just explain, in terms of concepts like project crashing, it's called many things, I understand, but can you just explain what it is and really what project managers maybe, or even site agents should be wary of?
Yeah, project crashing or critical path crashing, as it's often referred to, is simply looking at the activities on the critical path. These are your priority activities driving your end date, primarily related to time. It's looking at them and seeing what additional resources you could apply to those activities, which could reduce the duration of delivery on those. The benefit is obviously you're then giving yourself more opportunity to finish early. It also may lead to creating a new critical path through your project. As you reduce some activities, others may then become critical.
Right, and that's primarily about resourcing issues?
Yeah, and going back to the critical chain concept, if I were to apply resources to each of these activities, which is very easy to do, and again, software tools tend to allow you to put these in to enable you to level and optimize your resources, but it would possibly move your critical path through different activities if you've got resource constraints on any one or several of them.
But presumably it isn't as simple as saying reducing the time on the walls will mean doubling the amount of labour on the site, because that can lead to its own problems.
Absolutely. Each activity needs to be assessed on its merits, but again, as you progress through a project, you start learning. So after month or week 1 in this project, I've already now got some evidence of how long the earthworks might then take me. And each month you use that evidence to help you forecast and trend going forward.
Okay. What sort of, you've mentioned this, putting the contingency on at the end rather than each individual one. Are there other common problems that you find in critical path analysis?
Yeah, the biggest problems are keeping the plan up to date. We actually find that the logic breaks down if you don't link the activities together properly. So the logic needs to be applied, the right activities need to be there. If you keep that plan up to date and refreshed and discussed at your usual project meetings or whichever governance you apply, you're much more likely to understand the key priorities in your project, the areas of focus, the areas that you need to target as you progress.
Right, so that's the benefit of using a software package rather than doing it this old-fashioned way. Presumably you still have to build in the same model into the software package, but after then it pays dividends.
Exactly. To plan this project, you would do it exactly how we've done it and add 15 minutes on it to load it into a software tool. The benefits come when you are monitoring and controlling your project and having to make changes, because you can very quickly change the durations of activities and see how that affects the subsequent activities in your project. Obviously, it's very easy in this example. Projects that we run typically might have 200-300 activities, and very large projects, 2,000 or 3,000 activities.
Well, we've looked at small and medium projects, but for large projects, there's kind of control packages like Prince2, which we've actually done previous programs on in the NBS Learning Channel's back catalogue. That terrible acronym for projects in controlled environments. So what's your thoughts on those sort of software packages and others?
Yeah, Prince2 is a process for managing projects. It works very well if everybody understands the process. The components used to build up Prince2 are the same as any other project management body of knowledge. risk management, quality management, cost management, time management. All of these are essential elements. What Prince2 tries to do is define when these are used in a life cycle of a project. And it's been very effective in many projects.
Right. Just to come back on this one, because in our earlier graphic we showed activities on nodes and as a flow chart, and you've drawn this as a Gantt chart. Could you just give us a little indication as to how this might appear as a, I mean, unless it's not that spectacularly different, but can you just show how what activities on arcs mean?
Yeah, activity on node and activity on arc or activity on arrow really split the difference between an event and an activity. So if you have a key event, you would describe that as an activity on node. If you have work associated with completing that event, then your activity on arrow is how you depict it. It's just a different graphical representation of the same thing, the focus primarily being on time.
Okay. Right, well, just in terms, because I know that you've worked with the LDA on a number of projects, is there anything that you can show us some of the complexity maybe of the work that you look at rather than just a single house?
Yeah, I can show you one example of a project we're currently running, approximately £30 million, and this is how we would show that at a monthly report. It's probably about 60 pages of activities. No one would read it. So what we actually do is show simply the critical path for this, which would fit on a much more comfortable 2 sides of A4. That gives, as a management team, the opportunity for us to focus on the key activities. And of course, with 80 or 90 projects to review on a monthly basis, this is a very effective means of managing the key priorities on our projects.
So is there one final tip you could leave project managers with, what they should and shouldn't do?
Keep the plan up to date and accept that it's just a plan and plans change.
Excellent, excellent. Thank you very much. Well, in critical path terms, this is what we call a closing event. It's the point where I say thank you very much indeed to Martin Powell, Director of Project Delivery at the LDA, for sharing his knowledge on this deceptively complicated subject. Please have a look through the study notes and try the questions. But for now, Martin and I are going to beat a critical path to the coffee machine. See you next time.